Okay, so with this we are done with all the basic concepts of the fluid mechanics, fluid statics. So let me just very quickly go through all of them for a quick summary, right? So let's say this is a fluid element and this is another fluid element and both of them are connected, right? So if you look at this fluid element over here, this fluid element can apply what we call as push forces on this fluid element, and that is perpendicular to the surface. So only perpendicular push forces can be applied. In order to draw the free body diagram of my fluid element, I can have only three forces. The first force is my mg force, next force is my pseudo forces. Pseudo forces act when, let's say the acceleration of my fluid element is some a in some random direction. So the first thing I'm going to apply is mg in the downward direction. Then there would be pseudo force. So if I'm sitting on this, so if I'm looking at this from a non-inertial frame, I need to apply a pseudo force in this direction, right? So m into a. So I need to apply the pseudo force, and the next third thing which I need to apply are the normal forces. Now these normal forces are because of either normal reactions or the contact forces by other fluid elements. So this fluid element over here is pushing this fluid element. So these are my normal forces, right? In order to calculate these normal forces, we need to get three things, right? We need to understand what is its magnitude, we need to understand what is its direction, and we need to understand what is its point of application. Because for a force, these three things are important. Now, if you look at the magnitude of the force dF perpendicular, this is given by P, which is pressure at the point where you are applying the force, into dA. P into d. Direction is perpendicular and it's a push force. Perpendicular to the surface and it's a push force. And point of application is found using balancing of torque balance, right? So we've known how to calculate the normal forces by fluid elements. Now the thing is, in order to calculate the normal force, we need to know the pressure. So how do we know the pressure? Pressure is calculated using pressure gradient. Correct? Now we find dou P over dou R. So we calculate this pressure gradient, then using a known pressure. So if I know the pressure at this point, let's say the pressure at this point is some P, and I know the pressure gradient along this direction. So let's say this is my direction R, and I know dou P over dou R, right? So this is my pressure gradient along this direction. So this is R cap. I need to calculate the pressure at some random point, let's say this point over here, which is some point, let's say A. So pressure at A is nothing but pressure at P, which is P, plus you need to now integrate this over the entire length. So let's take the length, let's assume this to be a constant for the time being. So if this length is L, so this would be dou P over dou R. This is my pressure gradient times my L. Otherwise you would have to take dl and you have to integrate over the entire length, right? So this would be dou P over dou R into dr and integrate that over the entire length, right? So this is how you calculate the pressure at a point. Once you know the pressure at a point, you will get the force. Once you know the force, you will get the normal reactions and your free body diagram is completed. Once the free body diagram is completed, you can do other things in your fluid mechanics. So with this we are done, and we'll move ahead with some questions in order to understand कि हमने कितना समझा, correct? So we're moving to questions. Okay, so let's look at some of the questions by forces by liquid. So liquid कैसे forces लगाते हैं either on themselves or on some surfaces, उसके ऊपर कुछ questions करेंगे that will actually help us understand the concepts better. Our assumption that fluid is non-viscous, इसको याद रखना है because fluids cannot apply parallel forces. So the perpendicular force applied by fluid is P into dA. So you have to integrate P dA, pressure निकाल के integrate this over the entire area. You will get the force applied by the liquid. This is what we call as the resultant normal or the reaction force by the liquid. normal force which are applied by the liquid. And there were two cases we have seen. अगर आपको average pressure पता है, so what is F perpendicular? It's P average into A. और अगर pressure is constant throughout the area, so F perpendicular is simply P into A. Let's move to the first question. So first question says, neglect P atmosphere. So the pressure at this point is 0, pressure at this point is 0. So neglect the P atmosphere for the time being. You have to find the force by the liquid. So there is liquid filled inside this container. Find the force by the liquid applied on the base and ABCD. So base पर और ABCD पर what is the force applied by the liquid? So ये liquid इन पर forces लगाएंगे. We have to calculate what is that. This is a cuboid and the length, breadth, height are given to me, A, B and H. Okay, let's start with my base. So this is my base, this is given to me as A and this is B. So I need to calculate the forces applied by the liquid. So see, liquid, this is my liquid column. So liquid इसके ऊपर है, right? So liquid has to apply force perpendicular to it. तो यहाँ पर force लगा रही है liquid, यहाँ पर force लगा रही है. So liquid is applying the force throughout this column, right? In this way. But what do I know? Okay, obviously the gravity is there. So I know that there's G downwards, right? So because of this G, what I get a pressure gradient in this direction. So that is dou P over dou. Let me call this direction as Y direction. So dou P over dou Y. What is that? This is simply rho into G, right? Because acceleration is G. The forces you are applying is mg, right? So there's a gradient in this direction. Because pseudo forces जब हम बनाएंगे, pseudo forces में mg नीचे act करता है. So there's a gradient along the pseudo force, along the mg. Fine. So using this gradient, it is already given to me that you have to ignore any the P atmosphere, right? So pressure at this point is 0 because there is no atmospheric pressure. So pressure at this point is 0. I need to calculate pressure at this point. So pressure at this point would simply be 0 plus what is the pressure gradient along this direction. So let me write that. Dou P over dou Y is equals to rho into G. So pressure gradient along this direction is constant, rho into G. So मुझे यहाँ कोई integration नहीं करना पड़ेगा. I can directly write it as rho into G into height. What is the height? Height is given to me as H. So H. So pressure at this point is rho G H. See, अगर ये constant नहीं होता, right now the dou P over dou Y is rho into G. अगर constant नहीं होता, so मुझे क्या करना पड़ता? Dou P over dou Y को dl लेंथ लेके ओवर द इंटायर लेंथ इंटीग्रेट करना पड़ता, तब जाके मुझे प्रेशर इस पॉइंट पर मिलता. बट चूंकि द ग्रेडियंट इज कांस्टेंट, सो आई नीड नॉट टू एनी इंटीग्रेशन. डायरेक्टली मैं लिख सकता हूं रो इंटू जी विच इज दिस इंटू द हाइट एच. आई कैन राइट इट डायरेक्टली. सो प्रेशर एट एनी पॉइंट, यहाँ प्रेशर किसी भी पॉइंट पे लो, सो द प्रेशर इज कांस्टेंट. What is the pressure? Pressure is constant, that is equals to rho G H. ये हमने कैसे निकाला? With the help of pressure gradient, because there is a pressure gradient in the vertical y direction में एक pressure gradient है, correct? And अभी हमने देखा अगर pressure same है, so इन सब का जो net resultant force है, so I can directly write F perpendicular to be equals to the constant pressure which is P into the area of the base in which is A. So this is equals to rho GH into area. What is area of the base? A into B. So this is the net force applied by the liquid on my base, correct? And what is this is the magnitude. What is the direction? Direction is vertically downwards because it's a push force and vertical force. And what is the point of application? See, over here torque balancing की जरूरत नहीं है because since all these forces are same, I can directly apply that force at the center of mass which is the mid. Exact mid पे मैं वो force लगा दूंगा F perpendicular which is equals to rho GH into AB. Just a quick note, यहाँ मैंने ऐसा क्यों किया because आप जानते हैं कि अगर see basically हम जब सीडो फोर्स लगाते हैं, सूडो फोर्स को हम कहाँ लगाते हैं, सूडो फोर्स को हम सेंटर ऑफ मास पे ही लगाते हैं। उसका रीजन क्या होता है, द रीजन दैट सूडो फोर्सेस आर अप्लाइड टू सेंटर ऑफ मास इज बिकॉज एट द सेंटर ऑफ मास द torque for all those small forces is balanced. सेंटर ऑफ मास पे वो सबका जब हम टॉर्क बैलेंसिंग करेंगे तो वो बैलेंस हो जाता है। सिंस ऑल दिस फोर्स स्मॉल फोर्सेस, दिस इज डीएफ फोर्स, डीएफ फोर्स, डीएफ फोर्स, all these small df forces which are applied on small area on this, all of them are same. Since my pressure is same, all these small forces are same, so I can directly go to the center of mass and apply that force. So finally first answer हमारे पास आ गया है, what is the force applied by the liquid on the base, that is rho gh into ab. More interesting is what, so I'm just erasing this out, and उससे ज़्यादा interesting thing is to calculate the force on this surface A, B, C, D. Now this is a slant surface, right? So how do we calculate the force? Now firstly let me calculate the pressure on this surface. At this point the pressure is zero. That is very obvious, right? Because the P ATM is zero. P ATM you are set to ignore the atmospheric pressure, तो यहाँ सबसे ऊपर pressure zero हो जाएगा. Similarly इस point पर भी pressure zero होगा because this line is on the same level. And हमने पढ़ा था कि same level पर pressure same होता है अगर there were four conditions, अगर liquid same हो, liquid की density same हो, connecting हो and pressure static हो, so same level पर pressure same होता है. So pressure at this point would be zero. Pressure at this point or the entire line. So basically I will just calculating pressure along AD और ये पूरे line पर pressure same है. What is that? That is equals to rho GH और pressure यहाँ zero है. Since the pressure is increasing linearly in this direction, pressure is increasing linearly with the rate of rho into G. rho G के rate से pressure linearly increase कर रहा है. So अगर मैं यहाँ से कोई भी y distance लूँ and if I need to calculate the pressure at that, so what is P? P is nothing but 0 plus rho G into y. So if I just plot P with respect to y, that is a linear graph like this. So starting में 0 है, वो linearly increase कर रहा है. So यहाँ पर pressure 0 है, वो linearly increase करते it goes to rho G into h. Correct? So okay, I know the pressure at every point on this surface. So इस surface के किसी भी point पर अगर मुझे आप pressure पूछोगे, so I can directly tell you the pressure at this point. What is the average pressure? Since the pressure is not constant, so we cannot apply the direct formula F perpendicular equals to P into A. So let's see whether we can find the average pressure. Can we find the average pressure? अगर average pressure निकालेंगे, so we can use that formula. Average pressure निकालते कैसे हैं? If you remember average pressure, so average किसी भी चीज के निकालने के लिए what do you need to do? You need to integrate that thing throughout the area, right? So integration of dP. So integrate the pressure over the entire area. Okay, sorry, this has to be the small force, right? So what is the net force applied? So dF over integral dA. Okay, so let's do one thing. ऊपर से नीचे y travel किया and let's cut out a strip this way. Let's cut out this small strip जिसकी width हो जाएगी. So let me just erase these things. So ऊपर से y distance travel करके we are just cutting out a strip of length dy, right? इसकी length है dy. So इस पर we can assume the pressure to be constant. Pressure at this point is because of pressure gradient rho G into y, and we can assume that pressure to be constant throughout the small area of length dy. इस इतना small में तो we can assume that to be constant, and then we can integrate it to find the average pressure. So what is the small net force? So basically liquid is applying a force this way, right? Liquid is applying a force this way. So what is that small df? Df is integral PdA. So what is pressure? Rho G by, this is the pressure at that point, into its area. What is its area? This length is given to me as B. So the area would be B into dy. Correct? and divided by, what is its area? Integral dA. Area would be B into dy. So you can just work through this integration, and finally you will get the pressure is rho gh over 2. So this is the average pressure. See, mathematically you can very clearly see pressure at this point was 0, pressure at this point was rho gh, and pressure is increasing linearly from 0 to rho gh. So average pressure क्या होगा? दोनों का average rho gh plus 0 by 2. So you could have simply done it, but in more complex cases आपको ये फॉर्मूला लगाना पड़ेगा, which is average pressure is integral df over integral dA. Fine, so we've calculated the average pressure. Average pressure हमारे पास आ गया है. Now once we've calculated the average pressure, we can directly use the formula we can use the formula F perpendicular is equals to P average into A. So this would give me that the perpendicular force applied by the liquid on the surface A, B, C, D, this is equals to rho gh by 2 into area. What is the area of ABC? That is equals to B into H. So this is the force applied by the liquid on the surface. What is its? So this is its magnitude. There are three things. First is magnitude. What is its direction? So direction is quite simple. You could see that this is my surface. This is my surface A, B, C, D. What is the direction of force? So force is applied in this direction. So this is my direction, which is perpendicular to the surface. So force is applied in this direction with this magnitude. Now the question is, what is the point of contact? Point of application of the force? वो force यहाँ पर लगेगा, या वो force यहाँ पर लगेगा, या वो force यहाँ पर लगेगा. वो force लग रहा है इस direction में, that is quite easy to see. But where is that force acting? What is the point of application of that force? So if you remember, in order to calculate the point of application of force, so what we need to calculate now? Point of application of the force. So in order to calculate the point of application of force, you need to balance the torques. So अब हमें torque balance करना है. So basically speaking, this is the general formula which we've seen. So this is our rule, right? Just remember this rule. The point of application is where the total torques are balanced. So basically what I'm saying is, this is my surface, right? This is my surface given to me. This is my A, B, C, D. Look at the forces. Look at the forces. How are the forces applied? इस point पर liquid is applying no force. इस point पर pressure क्या है? 0. इस point पर pressure क्या है? Rho G H, and the pressure is increasing linearly, right? Average pressure is rho G H by 2. इस point पर there is no force applied, and इस point पर there is a huge force applied, dF, which is equals to rho GH. So obviously into dA. So यहाँ अगर कोई पतली सी स्ट्रिप काटोगे तो that is the force which is applied on that. So अगर मैं AB line, this line पर देखूं, तो इस line पर this is how the forces are applied, right? So this is how the forces are applied on this line. So इस पर अगर छोटी सी स्ट्रिप अगर मैं काटूंगा, like पतली सी स्ट्रिप, so on that strip the pressure is rho gh, so the force applied is rho gh into dA. इस point पर जाऊंगा, so it is half of that, right? So it is simply rho gh. At the half point, it is rho gh by 2, that is my pressure into dA. So the force is half of the force. Similarly, इस पूरे line पर the same small half force is applied. And in this way, this is my free body diagram of ABCD. Basically, this is how the forces are applied by the liquid. So the liquid is applying forces this way. This is what I'm drawing, the force applied by the liquid on the surface ABCD. And this force is applied completely this way throughout. These are all the small df forces which are applied by the liquid on the surface ABCD. Now that is not constant. So what I'm trying to do, this entire diagram would be equivalent to this diagram. So this is my surface ABCD. Okay, let me make it better. So this is my surface ABCD. A, B, C, D. From above, let's say at some point R, a net force, this is my F net perpendicular. What is its value? Its value is rho GH by 2 into the area. What was the area? It was B into H. So this total net force F perpendicular is applied by the liquid perpendicular to the area ABCD. Push force, right? But what is this R? We need to find what is this R. किस पॉइंट पर वो नेट फोर्स लगा रहे हैं, so that the torques of all the small forces are balanced by this net total F perpendicular force. So let's balance out the torques. So what are we going to do? We are going to balance the torques. Correct? So सबसे पहले we will find, okay, now the important thing is to balance the torque about any point. किसी भी पॉइंट पर यू कैन वेरी सिंपली बैलेंस द टॉर्क. देयर इज नो हार्ड एंड फिक्स रूल कि इस पॉइंट पर ही टॉर्क को बैलेंस करना. यू कैन चूज एनी पॉइंट. सो फॉर द सेक ऑफ सिंप्लिसिटी आई एम चूजिंग दिस पॉइंट टू बैलेंस आउट माई टॉर्क. इस पॉइंट पर मैं दोनों साइड के टॉर्क को बैलेंस करने वाला हूं. सो इसका टॉर्क निकालने के लिए टॉर्क ड्यू टू एफ नेट, ये दैट इज क्वाइट इजीली सीनेबल. So torque is in this direction. So basically this force is trying to rotate this ABCD area in an anti-clockwise direction. So torque का direction ये है और उसका magnitude क्या हो जाएगा? F perpendicular into this R. So this simply would be rho GH by 2 into B into H. Correct? So this is quite easy. Let's calculate the tau net due to all these small df forces. उनकी वजह से कितना टॉर्क आएगा. So in order to calculate that, you need to integrate all the small torques, right? So let me draw my surface once again. अब यहाँ से किसी y डिस्टेंस की दूरी पर हम एक छोटा सा स्ट्रिप काटते हैं. Correct? Now, what is the force acting by the fluid on this small strip? What is the force acting? So, okay, these are small forces acting over the entire area. और चूंकि these forces are same, इनका आप इसके center of mass पर force लगा सकते हो. ये चीज समझ में आई, right? Because these small forces are acting over this small strip, and those small forces are same. चूंकि वो सारे forces same हैं, तो यू कैन अप्लाई दिस कॉन्सेप्ट, जो कॉन्सेप्ट हमने बेस में फाइंड करने के लिए यूज किया था. दिस गाय F perpendicular is P into A, and that is applied on the center of mass of the area, right? So यहाँ पर you can apply that concept, और यहाँ पर force is simply, this force is simply going to be the pressure. Pressure is rho Gy into dA. What is the area? So let's say this width is dy. So this would be this is B, I guess. Yes, it is B, and this is dy. So B into dy. So this is the force acting at the center of this. So from here, this is B by 2, right? This is B by 2. So at B by 2 distance, this force is acting by the fluid on this small strip. So इसके वजह से अगर हम छोटा सा टॉर्क लिखेंगे, so d tau. So let me just write here. So d tau vector अगर मैं लिखूंगा, so obviously that all the torques are in this direction. So सारे torques anti-clockwise है, so they are gonna add up like scalars, right? सारे torque इसी direction में है, तो वो about this point we are calculating the torque, so वो सारे directly बस add हो जाएंगे. So इस point पर सारे d tau हैं, वो सारे add हो जाएंगे. d tau that would be equals to rho Gy into B dy into y, right? This is my length y, So what is torque? Torque is nothing but F into R, right? जो force है into कितना distance है we're calculating tau. This is torque about a single point, right? So we're calculating torque about this point. So the force into the length. This is d tau. So you can, in order to calculate the net force, now what you need to do? Just integrate all this. So F net, F total by all the small forces, this is equals to integral d tau. So just integrate this torque. Okay, so this would give me integral rho gy into b into dy, and you can integrate it from 0 to r, and that is going to give you, this is going to give you, so you can just write this integral of pda, this is my force into the y, and this is going to give you rho gh cube into b by 3. Okay, so you've got this torque on the left hand side, you've got this torque on the right hand side. In order to find the point of contact, what you need to do is to balance these torques. So after balancing the torques, so basically you need to do rho gh by 2 into b into h, that is equals to rho gb into h cube by 3. So from this you're gonna get y is equals to 2h by 3. Okay, this is r, right? Just a second. F perpendicular into r, so this would be r over here. Rho gh by 2 is my into bh, and you have to multiply it, so this is multiplied by r. So this is y, which is r, nothing. So this is 2h by 3. So basically my force is acting at 2h by 3 length. So this force, so this is entire h. So at a distance of 2h by 3 at this point, the liquid is applying its net force, which is rho gh by 2 into bh. With this, we are done with the question. So quick recap. Base के लिए find करने के लिए, base, so the liquid is applying a force on the base this way in the perpendicular downward direction. The liquid is applying a force on ABCD, जिसका magnitude we have calculated using the average pressure. So magnitude is using the average pressure into the total area, which is B into H. और वो कहाँ पर अप्लाई हो रहा है? What is its point of contact? So यहाँ से 2h by 3, so इसको 3 हिस्से में बांट दो. So इसका 2h by 3 distance पर इस point पर the liquid is applying a force on this surface in this direction. So these are the two forces which were asked. We calculate this force using the formula P into A because the pressure was constant. We calculate this force using the formula average P into A. Now there's one more conclusion from this question which we can get from here. The conclusion is base के ऊपर कितना फोर्स लगता है. सो बेस के ऊपर, सो दिस इज एक्चुअली अ जनरल कंक्लूजन व्हिच यू कैन फाइंड. आगे जब क्वेश्चन करेंगे सो यू कैन जस्ट रिमेंबर दिस कंक्लूजन. बेस के ऊपर जो भी लिक्विड कॉलम है, बेस के ऊपर लिक्विड का जितना भी कॉलम बचा हुआ है का वेट होगा वही बेस पर फोर्स होगा. So what are we saying? This is my base, right? इस बेस के ऊपर मेरी लिक्विड की कॉलम होगी. So this is my liquid column. So इस लिक्विड कॉलम का जो भी वेट W है, that weight, that entire weight gets transferred on my base as force. This is, so the force on the liquid columns, the force on the base is equals to the weight of the liquid column, which is above the base. So this is a general rule which you can remember. आगे आने वाले questions में you will see that this rule is also applicable.